Okay, Algebra 2, today we're going to be learning about solving square root equations. Now keep in mind, there are multiple different types of square root equations, different things that can be set up, but we're going to show you specific problems and specific examples, and tomorrow we're going to do more of the same stuff, but a little more complicated. So I have 4 examples to go through today. The notes are bizarre, but they're good. So I know whenever I sit down and read notes like this, like pre-filled in notes, my brain doesn't do that well, but these notes are actually solid. And these will be like, you need to take these notes, you need to fill them out, you need to get this done because this will help you big time. These are actually very solid notes. So if you're like me, and it's hard for you to read all this stuff, just go one step at a time. Start at A, read what's going on. Start at B, read what's going on. So I'm going to basically walk you through what's going on here. There are going to be examples where we have square root equations where you have 2 separate radicals. The radicals is this little house thing right here. There's a square root there. And so there's a method you can do. If you end up with this right here, an example like this is the best way to solve these types of problems. The first thing you're going to do is you're going to get one radical on one side and the other radical on the other side. And so let's look at it. A is given an equation, but look what happened here. You see how this is one big term minus another big term? Well, look on this side over here. Check it out. This didn't just move over. This x plus 15, the square root of x plus 15 didn't just move over. We added it. You can see it right here. I'm going to show you. We essentially added it to both sides. You don't have to write this down. Don't muck up your notes right here. These are pretty notes, but I'm just showing you that you can add more than just a number and a letter. You can add entire whole terms. So do you see how this would end up crossing out with this right here? But what's the rule? If you add something on one side, you must add it to the other side. So that's what's happening there. Again, don't write that down. Don't ruin your notes. But it ends up moving over, and that gives us down to B. So what did we do? We moved one radical to the other side. Moved one radical to other side. That's how we would solve these. And again, there's a lot of different versions of these types of equations, but we're going to give you all specific ones. So we moved it to the other side. That's how we got to B, essentially. All right, cool. How did we get to C? What happened with C? Well, check it out. The square roots are suddenly absent. That didn't just happen on its own. What did we do? Again, do not write this on your stuff. I don't want you to ruin your notes. We squared it. We literally squared it. Well, okay. I'm going to go up here. What happens if you have the square root of 4? Let's do square root of 9. The square root of 9 squared. What does that look like? Well, let's do it. Let's operate it together. The square root of 9, and I'm just making this up, y'all. The square root of 9 is 3. All right, I did that. I still have this square root. What happens, or what I square, when I square it again, I'm at 9. So do you see what happens? This house right here and this square cancels each other out, and you're left with just 9. So that's essentially what goes on here. So we squared both sides, and we're squaring both sides, the radical disappears, and now this is what we have. Now this is just a regular equation. So on C, square both sides. Both sides. And so side B, square both sides. Okay, square both sides. And now what's going on over here? Y'all, this is just regular math at this point. I'm going to say solve for x, like combine like terms, solve for x. So you can see what happened here. We moved this 1 over right here. 15 minus 1 is 14. And we also moved this x over. And we moved this x over like this. 3 minus 1x is 2x. So I'm going to say combine like terms for this thing, and then solve for x. Combine like terms. And yes, sorry for the handwriting. We know how it goes. Combine like terms. And then, solve for x. And then that's it. And you end up with x equals 7. Here's the deal. There are ways you can, whenever you start doing like square rooting and squaring and whatnot, remember how, I'm going to show you right here. Remember how technically the square root of 9 actually equals plus or minus 3, but we don't ever make y'all do that? It's because it's not always relevant. Sometimes it's relevant, sometimes it's not, and honestly, just like trusting the teacher, trusting us, and when we tell you this is relevant, this is not, until it finally clicks is the best course of action. But right here, just trust me that because of this whole square root business and introducing like 2 solutions, you may end up with multiple answers, and you may end up with answers that don't work. And answers that don't work are called extraneous solutions. So you have to go back to the original thing. Once you find your X, you have to go back to the original problem and plug it in and check and solve. And that's what you have to do. So you have to go ahead and check it. And you can see how they did it. If X is equal to 7, they went back to the original equation and plugged it all in. And they end up with the square root of 22 minus the square root of 22, which anything minus itself is a 0, and you end up with 0 equals 0. That is true. So it's bizarre, but go ahead and make sure you do that. I'm going to have this be the main lecture, video number 1, and I'm going to upload it now. And then I'm going to go to example 2. Yeah.